Welcome back, students, to the next screencast. This one is about simplifying radical expressions, and we are going to use simplification of radical expressions in a very real-world setting involving sea travel, and we're going to see how we can calculate very important aspects using square roots and simplifying radical expressions. Remember, the square root sign is a specific sign, but all of the different types of roots, square root, cube root, fourth root, fifth root, sixth root, seventh root, even the billionth root, which is possible, they all use kind of the same symbol. You've seen it before. It's called the radical symbol. All right, so what's the problem? Well, here's the problem. Kind of interesting. You may have known, or maybe you haven't, that there is a difference between a normal, what we consider a mile, which, if we're going to get technical about it, is technically, we should be calling it a statute mile. That's its actually kind of full name. Well, we know that is 5,280 feet, but there is a sort of longer version of a quote-unquote mile, but it's called a nautical mile, okay? Called a nautical mile, and it's 6,076 feet. And as you can see by comparison, it's just a slightly bit longer than a normal, what we consider to be a mile, which again is called a statute mile. So feel free to use that when you're talking about a mile. We are going to be dealing with nautical miles today. Now, for more information about what a nautical mile is, think of it as a slight breaking up of the Earth's circumference, also known as the equator, right? If you break up just a small sliver of that and you calculate the distance that the Earth rotates in 1 minute's time, you will have what's known as a nautical mile. Again, feel free to click the link below in the description of this video for more information about a nautical mile. Let's start to use it. It says, the visual horizon. We know what visual means. It means to look with your eyes. And horizon, well, we know what that is the distance you can see before your line of sight is blocked by Earth's surface. In other words, let's say you are on this boat right here, and you're traveling across the sea. As we know, because the curvature of the Earth is there, if we look straight ahead, we're not going to be able to see anything but, quote-unquote, the top of the Earth, or top of the curve of the Earth, and nothing really beyond that because the Earth sort of curves up. And so therefore, we're being blocked by the Earth's surface. So how far can you see from where you are to the top of the Earth's surface? That's called the visual horizon. If you are on a boat on the ocean, so let's say this is you, the visual horizon in nautical miles can be approximated by the expression, there it is, the square root of 4h. And remember, 4h means 4 times h. Now, what is h? It's our variable, and in this case, h is the vertical distance in meters from your eye to the water's surface. Remember, vertical means up and down, not left and right. That's horizontal. We're talking about the vertical distance. In other words, think of it this way. It's the distance from where your eyes are to the surface of the Earth, which means if you're higher up, that's going to be a higher vertical distance, of course, because it's the distance from where your eyes are to the surface of the Earth. So if you climbed a ladder, think of it that way, you're going to have a higher vertical distance than, say, if you were just simply standing normally on the ground. So let's see here. Suppose your boat is approaching a lighthouse from which your friend is observing you. So that's depicted right here. So your friend is right here on this eastern lighthouse, and you're coming in eastbound towards your friend in the lighthouse. All right, so we have a few things to answer based on that information. Now remember, the expression we're going to use, the square root of 4h. Remember, h is the vertical distance in meters. All right, so let's see the information that they present to us. Your eyes are 4 meters above the water surface. So you standing in the boat right here means that you are 4 meters above the water's surface. So kind of a lower boat. Your friend's eyes are 52 meters above the water surface. So your friend, who's all the way up probably at the top of the lighthouse here, if you measure from your friend's eyes down to the surface of the Earth, we're talking about a 52-meter distance. Now remember what those things are. If your eyes are 4 meters above the water surface, and your friend's eyes are 52 meters above the water surface, That's right. They have just given us h, the vertical distance for both us and our friend. We have to find your visual horizon and your friend's visual horizon in simplest form. All right, so let's get to it. And in order to get cracking on this, let's look at this information that they have given to us right here, and we've kind of organized here. So in this column right here on the left, we'll talk about all the information that discusses us, it's resting in the boat, and our friend, who's in the lighthouse. For both, however, us and our friend, we're going to use the square root of 4h to calculate this information. All right, so now what we need to know, again, we need to figure out what is this variable h. Well, as we saw earlier, all right, h is the vertical distance in meters from your eye to the water surface. For us, it is 4 meters, as we said earlier. And for our friend, it is 52 meters. So knowing that information, we know h for each. For us, it's 4 meters, and for our friend, it's 52 meters. And from here, we can continue to calculate. And so now knowing this information, we can begin to evaluate, aka plug and chug. So let's calculate for us first. I think that would be wise. So we know once again, it's the square root of 4h, and we know that h is equal to 4 meters. So knowing that h is 4, let's remove this h, and let's replace it with this 4. Now, of course, if we write it right next to each other, it looks like 44, but we know that's not what it's saying. We remember that 4h means 4 times h, so let's indicate that we are multiplying by putting parentheses around it, or even that little dot would work right here. Okay, so what we have here is, as we can see, the square root of 4 times 4. Now, in order to kind of work the square root of 4 times 4, we need to first simplify what is underneath the radical sign first. Since we know 4 times 4 is 16, what we are really looking at here is the square root of 16. And of course, we need to simplify that, okay? Well, the square root of 16, as we have seen before, is plus or minus 4. That's right, plus or minus 4. Now, what unit are we calculating in? Well, it started in meters, and this gives us the distance in nautical miles. So we can't just say plus or minus 4. We have to give it an actual unit, because we could be talking about, what, plus or minus 4 watermelons, plus or minus 4 planets? Who knows? No, it's nautical miles. Now, since we know the abbreviation for a mile is mi, remember, m is meter, mi is mile, but this is not a mile. This is a nautical mile. So the abbreviation for a nautical mile is nmi, which makes complete sense. Nautical mile. But let's think about also why this answer is not fully accurate in the context of the situation. Yes, the square root of 16 is plus or minus 4 because positive 4 times positive 4 is 16. And so too is negative 4 times negative 4, positive 16. But in the context of this situation, we don't need a negative 4 because negative 4 miles doesn't make any sense whatsoever. You cannot have negative distances. This is something we've discussed at great length in class. And because you can't have a negative normal mile, you certainly cannot have a negative nautical mile because those are both units in distance. So the true and correct answer that we are looking for is nothing more than positive 4 nautical miles for us. We have now calculated that r is 4 nautical miles. Now, for our friend, very similar math is going to occur, however, not so clean as numbers as the square root of 16. Let's remove this h and let's replace it with that 52. Remember, it is not 452, it's 4 times 52. So throw in something that indicates multiplication. I'm quite partial to parentheses myself, so let's go ahead and use that. Now, using similar mathematics, we know that we have to actually take 4 and 52 and actually multiply them together. And upon doing that, we get 208. So we're looking at the square root of 208. Now, 208 is not a perfect square. We have extensive lists that confirm that. So we have to ask ourselves, in order to simplify this, what two numbers multiply together to get me 208? One of them is, in fact, a perfect square. Well, there are many factors of 208. There's quite a long list. It's not huge. It doesn't go on forever, of course. But there are many factors. And if we look through our list of factors, we recognize that, well, if we're just identifying factors of 208 in which one of those factors, one of those numbers, is a perfect square, we can boil it down to 1 times 208. Another one is 4 times 52. And a final one is 16 times 13. So we have 3 different pairings to choose from. Now, for each, which one's the perfect square? Well, in the 1 times 208, 1 is the perfect square, but that's kind of small number. Plus, you never really want to work with 1 when you're doing this process because it gets you nowhere. 1 is quite negligible. However, this 4 times 52 and this 16 times 13, that's a little bit more intriguing. 4, of course, is the perfect square in this pairing, and 16 is the perfect square, of course, in this pairing. Which one do we want to use? Well, we've said it a few times before. If you always use the pairing with the highest possible perfect square, you will have the least amount of work to simplify. Yes, you could use 4 times 52. However, you would have to simplify yet again after that. So let's use 16 times 13, thus concluding we only need to simplify one more time past this point. Here we have the square root of 16 times 13, and we have learned that the the product property of square roots states that if you have 2 numbers and you're multiplying them together and they're both underneath the same square root sign, you can whoosh, slice it in half. You can fruit ninja that. And in other words, we can separate the 16 from the 13, and in doing so, both of them get their own square root sign, and we're on our way to almost being done with simplifying. So in order to do that, what we have to consider is, well, each piece individually. We know the square root of 16, of course, is plus or minus 4 once again, but remember in the context of this situation, we want the positive version. And the square root of 13, can that simplify any further? Let's see. Are there 2 numbers that can multiply together to get me 13? One of them is a perfect square, aside from the number 1. I don't think so. And because of that, what we have to do is simply leave this as the square root of 13. Alright, so this is 4 times the square root of 13 nautical miles. Alright, nice work. What we have done is we have calculated what we needed to calculate. And because of that, let's look back at our little diagram here with the boat and the lighthouse. Here we go. It's right here. Alright, so what we calculated here, all the way on the right, as you can see, is 4 nautical miles, and 4 times the square root of 13 nautical miles represents what again? The visual horizon. That's right. So let's go ahead and label it right here. So in other words, what we're saying with this visual horizon is the distance from you on the boat to this point right here where the Earth begins to curve and you cannot see past it. That's the visual horizon. Well, we calculated from us to the horizon right there is only 4 nautical miles, and the distance from our friend up here in the lighthouse to, again, that same exact point where the Earth starts to curve and you can't see past that from the lighthouse, well, that's 4 times the square root of 13, also known as 4 root 13 nautical miles. All right, good. So now that we have it here, we know this distance from here to here is 4 nautical miles, and the distance from here to here is 4 root 13 nautical miles. All right, good. Now knowing this, we can continue on to the second part of this problem. See, now this says, you will be able to see the lighthouse from the boat. You will be able to see the lighthouse when your distance from it, and by it they mean the lighthouse, is the sum. Sum. What does that mean? The sum of your visual horizon, which we calculated, and your friend's visual horizon, which we also calculated. So we got to figure this out. Find the value of each expression in part A to the nearest nautical mile. In other words, we have to create whole numbers, because rounding something to the nearest nautical mile means no decimals. We need to actually figure out what the distance is. Now, by saying 4 nautical miles, okay, 4 is, of course, a whole number. But 4 root 13 nautical miles, most people are going to ask, well, really? I don't know. Is that a large distance, a small distance? Is that long? Is that short? We have to actually put it into an actual number that our brains can better comprehend. 4 nautical miles is good there. However, if I were to ask you to approximate 4 root 13 nautical miles, or just in this case, 4 root 13 nautical miles, to the nearest whole nautical mile, that's what it's saying here, the nearest whole nautical mile, well, what we'd have to do is we'd have to use our calculator for that. So go ahead and put into your calculator 4 multiplied by the square root of 13, and you will clearly see that this is approximately, if you round to the nearest tenth, 14.4 nautical miles. But again, we don't want it to the nearest tenth. We want it to the nearest whole nautical mile. So if we were to round 14.4 to the nearest whole number, we would find out that that is, of course, 14 nautical miles. Remember, 4 nautical miles, that can stay where it is. That already is a whole nautical mile. 14 nautical miles, now that is the approximation of 4 root 13 nautical miles. All right, so how does this help us? Well, we have to use the results to determine how far you will be from the lighthouse when you first see it. Well, how do we calculate how we first see it? Go back to this first sentence. You will be able to see the lighthouse when your distance from it is the sum of your visual horizon plus your friend's visual horizon. So now, instead of thinking of our friend's visual horizon as 4 root 13 nautical miles, we have simply rounded that to 14 nautical miles, and our visual horizon still remains as 4 nautical miles. How do we find out what it's asking? In other words, the distance we will be able to see the lighthouse? Well, we have to find the sum of your visual horizon and your friend's. In other words, we have to take 4 nautical miles, 14 nautical miles, and add them together. Add them together, because it says sum. Remember, sum means the answer in an addition problem. All right, so we're pretty much done with this. 4 nautical miles plus 14 nautical miles. Very easy to calculate. That's right. 18 nautical miles. Nice job. We just answered the question. Use the results to determine how far you will be from the lighthouse when you first see it. You will be 18 nautical miles. In other words, if you're in the ship and you're approaching the ship, you will be able to see it within 18 nautical miles. Well, okay, one more thing to consider is the fact that most of us don't really think in nautical miles because that's really difficult for us to use because we don't use them every day. So what if I asked you to actually tell me in real life how many normal, aka statute miles, 18 nautical miles is? Here's how we'd figure it out. One thing we do is we do our research, of course, and we learn that for every 1 nautical mile, that is approximately 1.15 normal everyday statute mile. In other words, 1.15 mile, 1 15/100ths of a mile. All right, so knowing that, and as we can clearly see, because a statute mile is shorter and a nautical mile is longer, we clearly see that also we need more normal miles to make up 1 nautical mile because 1 nautical mile is, of course, longer. Well, the conversion is actually not that bad. We start with 18 nautical miles, and we're going to multiply that by our conversion factor. Because the nautical miles are going to cancel out, we want the nautical mile in the denominator, and we want the miles that we're trying to reach in the numerator. Now, which is a bigger unit? Which is a longer length? 1 nautical mile or 1.15 miles? Well, clearly, as we just saw earlier, a nautical mile is longer. So 1 nautical mile is going to yield 1.15 miles. And now we have 18 multiplied by 1.15 over 1. And of course, you can, think of this as 18 over 1. Well, what's going to happen is, just like numbers, as we've seen before, and just like variables, as we've seen before, units will also cancel out. If we have nautical miles in the numerator and nautical miles in the denominator, those cancel out. And what's the only unit that remains is miles. So in other words, we know how to multiply fractions. 18 times 1.15 is the numerator, and in the denominator is 1 times 1. Well, that's nice and easy. All we really are saying is what is 18 times 1.15. And if we approximate it accurately, let's not use the equal sign, let's approximate it, that's going to be about, and feel free to confirm this on your calculator, 21 miles. There's your number again, 21. I can almost hear some people at home, you know who you are, saying 21 the way you like to say it. You know who you are. All right, so there you go. 18 nautical miles is approximately 21 miles. Now, what does that mean for us in this situation? That means if you are approaching on this boat and you are heading towards the lighthouse, you will not be able to see it due to the curvature of the earth until you are 21 miles away, aka 18 nautical miles. Nice job. Now, here comes your problem, okay? It's not as involved, but it does involve a formula that requires square roots. Here it is. You are talking about now walking speed, excuse me. Your maximum walking speed in inches per second can be approximated using the expression the square root of 384 L. That's an L, not a 1, where L is your leg length in inches. Suppose your leg length in inches is 28 inches. In other words, your leg is 28 inches long. Write an expression in simplest form for your maximum walking speed. Then approximate the speed to the nearest inch per second. Remember, that is a whole number. So you're going to have two answers. One of them is going to be the expression in simplest form, and then you're going to take that and you're going to round it to the nearest whole number, which is the whole nearest inch per second. All right, so here's a little, I don't know if you want to call it a diagram of it. What this is saying is use the expression the square root of 384 multiplied by L, and L is your leg length, of course in inches, and they're saying it's 28 inches. So in other words, what that's saying is, let's say you are this gentleman right here. The leg length you have, in other words, the distance from your waist to the bottom of your foot, is 28 inches. Knowing that, how can you calculate your maximum walking speed? And by maximum walking speed, meaning how fast you can walk if you're really, really pushing yourself. And remember the difference between walking and running, okay? There is a difference. When you are walking, there was always at least 1 foot touching the ground. But when you're running, that is not the case, okay? Both feet are up in the air for just the shortest amount of time. That's the difference between walking and running, or even walking and jogging, okay? So if you're really pushing yourself to walk as fast as possible, this equation, this formula right here, this expression, is going to be able to give you that maximum walking speed. All right, so now, based on that, feel free to use all this information right here and tell me both answers. And for a little extra bonus, once you get your answer and you state it in inches per second, feel free to go ahead and convert that to feet per second to get a better understanding of how fast you can walk if you have a 28-inch leg. If you have any questions, feel free to contact me. Good luck.